Okay, once you've got this written down on your table of contents, grab that yellow page with the exponents, so using properties of exponents. Grab the yellow page. Okay, so flashing back to Algebra 1, we had these exponent properties. Okay, and as a reminder, we're going to go through them. This is going to go on page 56, by the way. Okay, so it says solve the following problems by writing them in expanded form. Okay, well, 2 to the third power really means 2 times 2 times 2. And 2 to the fourth power really means 2 times itself 4 times, right? So how many 2's am I multiplying together? Good morning. So how many total 2's am I multiplying together? 7 of them. So can you rewrite this as 2 to the 7th power? Okay, is there something I can do with 3 and 4 to get 7? I could add them. All right. Then we're going to do the same thing with this next one. 3 to the 4th power is 3 times itself 4 times. And 3 to the 3rd power is 3 times itself 3 times. So what happens when you have the same thing in the top and the bottom of a fraction? They cancel out. So 3 of these are going to cancel out, and I'm going to be left with 1 on the top. So it's really just 3, or 3 to the 1st power, right? Can I do something with the 4 and the 3 to end up here? Subtract them. Someone whispered it. Okay, so we noticed that here with the powers, 3 plus 4 is 7. When we were multiplying, if we added the powers, we could get the correct answer. When we were dividing, 4 minus 3 is 1, which would give us our 3 to the 1st power, which is our answer. Do you remember that from Algebra 1? Seen these things before in your life? Yes? No? Okay, 2 people remember. All right. Okay, so these are all the properties of exponents, and you are going to need these a lot, so you might as well just embrace them. Okay, when we were multiplying and our base was the same, we could add our exponents, so a to the m plus n. When we were dividing, we could subtract the exponents, so a to the m minus n. Anybody remember what you do when you raise a power to another power? Yep, you multiply them. So mn, or m times n. Okay, then we have the negative exponent. This is kind of the one that gets people. But you can't have a negative exponent in your answer. So you have to move it to the other part of the fraction. So like right now, this is a to the negative m over 1. To make that exponent positive, you have to move it from the top of your fraction to the bottom of the fraction. So this is going to be 1 over a to the m power. Okay, we also have the 0 exponent. Anything to the 0 power, does anybody remember that one? It's 1. It's a weird one. Anything to the 0 power is 1. When you have a power of a product, so you have things that are multiplied in here. Notice these are multiplied. If the stuff on the inside of the parentheses is being multiplied, then you can distribute the exponent. If it's being added or subtracted, that does not work. But if it's being multiplied, you can distribute. Or if it's being divided, you can distribute. Okay, so exponent properties, they're going to give you a problem and say simplify. And what you have to remember is your answer can have no negative or 0 exponents. All right, so now you've had a little bit of a refresher. I want you to go ahead and try, when you open up that book on the left-hand side, I want you to go ahead and try those first 6. Okay, here's the answers to the first 4. You remember doing stuff like this now? Okay, number 4 looks scary, but anything to the 0 power is just 1. So it doesn't matter what's on the inside here, because it's to the 0 power. Anything to the 0 power is just 1. Okay, I was going to work through 5 and 6, because those are a little bit more complicated. All right. Everything on the inside of these parentheses are being multiplied, which means that I can distribute the 3 to all the pieces, my exponent of 3. So this is 3 to the 3rd power times x to the 6th power, thank you, times y to the negative 3. Okay, so I need 3 to the 3rd power. Well, 3 squared is 9, and 9 times 3 is 27. So 27, x to the 6th, y to the negative 3. But can I have a negative exponent in my answer? No. So I need to move this term to the other part of my fraction. Right now it's in the top, because when I don't have a fraction, you just assume it's the whole thing over 1. So I need to move that to the bottom of the fraction to get that negative to go away. So this is going to be 27 x to the 6th over y to the 3rd power. Okay, so number 6 is pretty complicated, right? There's lots of letters and numbers and exponents and all the things. So I'm going to break it down piece by piece. So I'm going to break it down into the numbers first, 2 over 4, times, I'm going to make a piece of just x's, so x squared over x. I'm going to look at just the y's, so y to the negative 4 over y squared. And then just z is z to the 0 power. And then I'm going to look at each piece individually. So if I just look at 2 over 4, what does that simplify to? 1/2. Right? Then look at x squared over x. What can you do with those exponents? Subtract them. What is 2 minus 1? 1. So this is going to be x to the 1st power. Then I'm going to look at the y's. I have y to the negative 4 divided by y squared. Just like last time, we can subtract to the exponents. What's negative 4 minus 2? Negative 6. And then anything to the 0 power is just 1. Okay, so now it looks a little less scary. I'm actually going to make these fractions. Okay, this x has a positive exponent, so I'm not going to mess with it. I'm going to leave it just like it is in the top of my fraction. But the y has a negative 6 as the exponent. You can't keep a negative in your answer, so I have to move it from the top to the bottom. So in the top of my fraction, I have 1 times x to the 1st power, which is just x. In the bottom, I have 2 times 1, which is just 2. And then when I move this y to the negative 6, it's going to become y to the positive 6. And then I have this times 1 here at the end, but if I multiply by 1, is that going to change anything? No. So this is my answer. So if you notice, all the ones on the right side of this page look really scary, but you just have to take them one piece at a time, one variable, one letter, whatever, one piece at a time, and then they become less scary. All right? So I want you to go ahead and try 1 and 2 on that next side. Okay, so I started them both. So on this first one, you have 3 to the 4th times w to the 4th all over z to the negative 2 times w to the 4th z to the negative 2. Okay, well, the first thing that I notice is I have a z to the negative 2 in the top and a z to the negative 2 in the bottom. So those are going to cancel, because it's the same thing in the top and the bottom. 3 to the 4th power, that's 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. That's going to be 81. And then I have w to the 4th times w to the 4th. What can I do with those 4s? Add them to get w to the 8th power. And then that's it. Okay. For number 2, I have negative 3 to the 3rd power times a cubed times a to the 9th times a to the negative 7. So negative 3 times negative 3 is positive 9, and positive 9 times negative 3 is negative 27. And then with all 3 of these terms right here, I can add those exponents. 3 plus 9 is 12, and 12 plus negative 7, or 12 minus 7 is what? 5. So you get negative 27, a to the 5th power. You don't have any negative exponents or 0 exponents. So that's the answer. All right, number 3. Right here, since these variables are being multiplied, I can distribute the 2. So that's going to give me c to the 8th power d squared over c to the 9th d squared. Again, you have the same thing in the top and the bottom, so those are going to cancel. What is 8 minus 9? Negative 1. Can you have a negative exponent in your answer? Nope. So we're going to move it to the bottom of the fraction and make this 1 over c. All right, number 4. Looks a little intimidating. Okay, but the thing we need to focus on first is the fact that we have a division symbol here. Who remembers how to divide fractions? You remember? All right, you keep the first one the same. You flip the second fraction, and then you change your sign to multiplication. Keep, flip, change, or KFC. Keep, flip, change. All right, so this first fraction is going to stay exactly like it is. Our second fraction is going to flip, and we're going to change it to multiplication. So while I'm keeping this first one, I'm going to distribute this negative 3 exponent to all of these terms. So I'm going to do negative 2 to the negative 3, x to the 12, y to the negative 6, over x to the negative 9, c to the 3rd power, I'm going to flip this fraction over here. So the 6y to the 5th, z to the 5th is going to end up in the top. The denominator, I'm still going to have this 3. And I'm going to have x to the negative 14 y squared. I'm going to change from division to multiplication. Okay, it's still an ugly problem. Okay, so the way that I approach it is I'm going to combine everything in the top and then everything in the bottom, and then I'm going to simplify. You can start by simplifying each piece and then multiplying them together. It's really up to you, but I like to combine all the way across first to make my life a little bit simpler, so I only have to simplify one thing. Okay, so I'm going to have across the top, actually I lied. I'm going to move this one to the bottom. I didn't lie. Okay, I have to move that to the bottom because it's got a negative exponent. So I'm going to have negative 2 to the 3rd power in the bottom. And then across the top, I'm going to have a 6. I have 12 x's. I have y to the negative 6 times y to the 5th. Negative 6 plus 5 is negative 1. And then z to the 5th. Okay, now in the bottom, I have this negative 2 to the 3rd power that I moved from here. I have a 3, so times 3. I have x to the negative 9, x to the negative 14. So negative 9 plus negative 14 is negative 23. And I have a y squared and a z cubed. Yeah, I can simplify some more in the denominator here. So right underneath this, I'm going to simplify it one more time. Okay, so I have negative 2 to the 3rd power. That's negative 2 times negative 2, which is 4, times negative 2, which is negative 8, times 3, which is what? 8 times 3? 24, so it's negative 24. So I have 6x to the 12, y to the negative 1, z to the 5th, over negative 24, x to the negative 23, y squared, z cubed. Okay, so just like I did on one of those on the left-hand side of the page, number 6 on the left-hand side, I'm going to take this one piece at a time. So I'm going to start with just these numbers. Okay, if I have 6 over negative 24, do you see that that simplifies to negative 1/4? Okay, so I have negative 1/4. Then I'm going to look at just the x's. I have x to the 12th over x to the negative 23rd. Twelve minus negative 23. Is that 35? What's y to the negative 1 over y squared? That's negative 1 minus 2. What's that? Negative 1 minus 2. Come on, people. Thank you. And then 5 minus 3 is 2. Okay, now that I have each piece, I have to simplify. I can't have a negative exponent, right? So I'm going to make this negative 1 x to the 35 z squared over 4y cubed. Okay, so lots of steps, but each piece you can do. All right? Yes.
When you're distributing the food, why did you just only add 1?
Where?
The first line.
Why did I only add 1? Where?
X negative 14 number. Why is negative 3x? So the negative 14 power through y.
Right here?
Yeah.
Okay, so the 3 is not inside the x, or inside the parentheses, so the 3 stayed. 2 times negative 7 is negative 14. This is y to the first, and 1 times 2 is 2.
Yeah, but why doesn't the y have a 3? You can redistribute that 3, don't you?
Well, no, because these are all being multiplied. If they were being added, then you would distribute the 3. Okay, for the sake of time, we're not going to do 5 or 6. All right, but they're there. All right, so we're going to go ahead. That goes on page 56. And then page 57 is going to be that tan paper. I'm going to put it in sideways. Grab a calculator. Right here. All right, polynomials. So this is all review from Algebra 1. We actually took this chart from some Algebra 1 notes. So we're going to go pretty quick. All right. Polynomials are named according to their degree and number of terms. So the degree comes from their highest exponent. So if it's a degree of 0, that's a constant. That means there's no variable in your expression. So an example of that would be the number 2. If you have y equals 2, that's a constant function. it's degree 1, it's a linear function. Example of that would be x minus 1. The exponent on that x is a 1, so it's a linear function. Does anybody remember what degree 2 is called? You should really know this. We just took a whole test over it. That's number of terms. Starts with a Q. Quadratic. An example would be an x squared plus x minus 2. Seen some functions like that before? Yeah, no, none. None on that test you just took. All right, degree 3 is called a cubic function.
Can you graph that?
We will. This unit. Uh-oh. Okay, now we're getting into my two favorite names for functions. Fourth degree is a quartic, like a quarter. And 5 is quintic. Okay, and these are just random made-up functions. They don't have any real significance. All right. And then anything with a 6th degree or more is just called an nth degree. So whatever your n is, whatever degree, is called that degree. So a 6th degree or a 7th degree, 8th degree, 9th degree, blah, 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 blah. All right, then you can also name it by the number of terms it has. If there's just one term, it's called a monomial. No matter what degree, if it's just one term, it's a monomial. If it's 2 terms, what's that called?
Binomial.
What?
Binomial.
Binomial, yes. You can grab a calculator. Okay. And about 3 terms. Trinomial. And then if it's 4 or more, it's just called a polynomial. Okay, and then you always need to put polynomials in standard form. When you're writing your answer, or if you're going to name it, because sometimes if it's not in standard form, then you will miss something and misname it, which would be sad. Okay, so then there's 3 tiny examples right here. So go ahead and name those 1, 2, 3 expressions based or using these names up here. You're going to have 2 names for each one. You're going to name it by the degree and the number of terms. So just name it right here, real quick. I'll give you like 2 minutes. You ready to check them? Okay, so the first one has a degree of 3, has 2 terms, so it's a cubic binomial. Second one is just the number 5, so it's a constant monomial. And the third one has a degree of 4 and 3 terms, so it is a quartic trinomial. All right, go ahead and glue that in on page 57. And the good news about the rest of today is I'm not teaching you anything new. We've done everything else the rest of today already this year. It's just review. Go ahead and write these in on page 57. Okay, adding and subtracting polynomials. It's just as easy as you remember. All you're doing is combining like terms. And we're going to put our answers in standard form, meaning we're going to start with our biggest exponent and work our way down to our smallest exponent. Okay, so I'm going to combine these x squareds first. Negative 3x squared plus 4x squared is 1x squared. Plus 7x minus 9x is minus 2x. And you still have that plus 6. And that is my answer. And then I have to name it. Again, each name is going to have 2 parts. It's going to have a name by the degree and a name by the number of terms. So a degree of 2 is a quadratic. When it has 3 terms, it's a trinomial. So this is a quadratic trinomial. Okay, part B, we're subtracting. So just like last time, I'm going to distribute the negative. Combine like terms. Thank you. So the first one does not change. It's 2x cubed minus x squared plus 3. Second one becomes plus 5x squared minus x cubed plus 6 minus x. Then combine your like terms. So I'm going to start with my biggest exponent of 3. 2x cubed minus x cubed is x cubed. And my x squared, negative x squared plus 5x squared is 4x squared. There you go. All right, then I have a minus x and plus 3 plus 6 is a plus 9. And then I have to name it. have a degree 3 with 4 terms. Degree 3 is cubic. 4 terms is polynomial, so a cubic polynomial. Okay, go ahead and do those next 3 without me, and we'll check them. Here are the answers to part C and part D. Okay, and we're going to talk about part E. When we did these last time, I showed you how you can kind of line them up vertically, and a lot of you really liked that, so I'm just going to remind you. So what I'm going to do is I'm going to take each of these 3 pieces, and I'm going to put them in standard form, and then I'm going to stack like terms on top of each other, rather than trying to do this horizontally like I did the other ones. So I'm going to take this first one, I'm going to do x cubed first, plus 2x squared minus 3x. So all I did was rearrange it to where it's in standard form. And then I have plus this second expression. So I'm going to do the same thing. So I'm going to put the negative 4x cubed underneath the other x cubed. I'm going to put the 5x underneath the other term with x. And then plus 9 down here on the end. And then this last one is a subtraction. So I'm changing all of the signs. So when I write it, I'm going to stack those underneath the other like terms. Thank you. So I'm going to have a plus 2 down here under the 9. I'm going to have minus 5x under the other 5x. I'm going to have a plus 6x squared and a minus 8x cubed. So when I stack it vertically that way, it's way easier to see your like terms. So right here, I'm going to have 1x cubed minus 4x cubed, which is negative 3, minus 8 makes it negative 11x cubed. 2x squared plus 6x squared is plus 8x squared. Negative 3x plus 5x minus 5x, those cancel. So it's just going to be a minus 3x. And then plus 9 plus 2 gives you plus 11. And then once again, it's a cubic polynomial. You do not have to stack them vertically like that. You do whatever works for you. Just giving you that option because it's an option. Okay. Now we're going to go to page 59 and we're going to do some multiplication. It's the last page for today. Last page notes. As a reminder, you already know how to do these. If you just want to ignore me and then work them out and check your answers in a second, you can. Otherwise, I'm going to work them out. You can do it with me. Okay, so I'm going to multiply my first term times both terms in the second set of parentheses. 3x times x is 3x squared. 3x times 5 is 15x. And you're going to do the same thing with your second term. Negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. Then combine your like terms to get 3x squared plus 11x minus 20. It's degree 2 with 3 terms, so it is a quadratic trinomial. Okay, part B. The way I recommend doing these problems is to ignore that third set of parentheses, multiply the first two, and simplify, and then multiply the third one. Don't try to do all three at the same time because it won't work. It'll give you the wrong answer.
Why not?
Because it's complicated. Just don't do it. So we're going to multiply the first two. So you get x squared minus 6x plus 3x minus 18. We have that x plus 2 that we're going to ignore. Combine your like terms to get x squared minus 3x minus 18 times x plus 2. Okay, and then we're going to multiply again. You're going to multiply each term in the first set by both terms in the second set. So I'm going to have x cubed plus 2x squared minus 3x squared minus 6x minus 18x minus 36. And then combine like terms. Do x cubed minus x squared minus 24x minus 36. We have a degree 3, so it's cubic. We have 1, 2, 3, 4 terms, so it's a polynomial. Yes. Yep. So the homework is going to have the exponent rules, the naming, and then add, subtract, and multiply. Should be pretty easy. All right, try those next two. And as you're working them, don't forget that this really means 2x minus 3 times 2x minus 3 times 2x minus 3. That is not one where you can just distribute. There you go. Here's this last two. There's about 3 minutes left. I've already posted the homework.
Ms. Stewart,
Yes,
4 times 2 is 9.
you're right. 4 times 2 is 8, not 6. All right.